Welcome, everyone. This is our session 2 on Listeria monocytogenes. Welcome back for those that attended our session that preceded this. For those of you who weren't here, my name is Donna Garren. I'm with the American Frozen Food Institute, and so pleased that PROCESS EXPO sought us out to do a session specifically on frozen food and different sessions. We'll be doing one tomorrow on FSMA, Food Safety Modernization Act, and the frozen food sector. Yeah, love those regulations. So again, as I mentioned in the earlier session, we have Dr. Kelly Stevens back with us. She is with General Mills, great member company of ours, and we're so pleased to have her. And she's going to really go over kind of what we heard in the introductory session. We heard about the regulations, we heard about it being in plants, how to go out and find it, seek it out, what type of programs to set up, particularly for testing. Now we're really going to talk about sanitation and design that can help you reduce Listeria monocytogenes in your plants. I'm sure that this is near and dear to the hearts of many who attend this particular show about equipment and facility design and how important it can be. So without further ado, because this is a really large topic, and Kelly does a great job. She's done this for our member companies in the past, and I really wanted her to be able to share her knowledge here today as well. She is going to, again, take this next session, Controlling Listeria monocytogenes, Sanitation, and Sanitary Design in Frozen Facilities. Kelly?
Thank you, Donna. All right, so it's only an hour, and I think this is the kind of topic that you can talk for quite a while about. So what I'm going to do is really just try and hit some of the highlights and share some pictures of where we have really done a deep dive into some of these principles and where we've identified opportunities, and share some of the things that we've done to improve on the sanitary design. The reality of many of the systems that I know we have in our network were designed years and years before people were really fluent in the conversation around sanitary design. And it really is a learning journey. It's about having the right solution at the right time for the right process and the right equipment that you're using. And it's about finding the right solution, but sometimes not always the best solution. And definitely, if I had thought differently about how I prepared today, I would have taken us on a tour of the floor as we talk about the principles. But really hope and encourage everybody as you're thinking about this and as you're interacting throughout the next day or so to really ask some different questions as you're interacting with vendors and use a different lens as you're looking at equipment throughout the day. So we'll talk briefly about sanitation. We'll talk about sanitary design principles for facility and equipment. And then we'll have some pictures, and we'll get the chance to be a little bit interactive, at least inside this room. And I think really the big question is, why on earth would we even want to have this conversation? Why do we clean our plants? Why do we want to have equipment and facilities that are designed with sanitary design in mind? Depends on your product, depends on your process, but there's a lot of reasons out there. We'll focus very much on microbiological control today. I'll also talk a lot about pests, because I think when you find situations that are conducive to pest harborage, you begin to develop opportunities for microbiological harborage somewhere else in your facility as well. So let's start with sanitation. We talked about sanitation as we looked at a systems approach for control of Listeria. Sanitation is really all actions that are dealing with cleaning or maintaining the hygienic conditions of the facility. And this can range from the cleaning and sanitization of specific equipment and food contact surfaces to those periodic cleaning activities that you do throughout the facility, including the building, the structure, and the grounds. We talk about wet sanitation in the 4x4 process. We were joking around during the break about how fun it is to have the hoses and to be able to spray and go at the facilities. And sometimes if you have the opportunity to be there when your sanitation crew is cleaning, it looks like a bunch of firemen sometimes. You've got some high pressure hoses, really trying to get into some difficult places. Sometimes they're using water to move materials, and sometimes they're using water because they're just waiting for the next opportunity to clean something. But there really is a lot of science that goes into cleaning, and you need to be aware of the materials and the chemicals that you're cleaning with as you look at bringing new equipment into your facility. We were recently challenged with how could we do 3D printing of replacement parts, and it brought up a great question around, was the material even approved for use in food contact surfaces, and then how would it interact with the cleaning chemicals that we already had in our plants? So although the graphics and the explanations of the sanitation and cleaning procedures for wet sanitation are very straightforward, there's an awful lot of science and chemistry that goes into it, and also a lot of interaction with the materials. Many of us know that when you don't use stainless steel in the facility, we have to then manage some of the outcomes of that. Nothing like that aluminum system that sits in your wet wash area that eventually rusts by day 2. And then how do you manage that chemistry? So again, it's that interaction of the two, because as I think about putting equipment into my facility, as I think about building a new facility, at the end of the day, I want to be able to clean it effectively, and I want to be able to have a procedure from the people doing the cleaning that is safe for them to execute, and they can do so in a way that's repeatable every time and sustainable. Hence, that leads us to the importance of sanitary design. And I was talking to somebody earlier today about this term, and it really implies that you have an engineer in an office that's very, very clean as they're designing the system. Well, that's not really what it means, right? It's about the application of those design techniques to allow that efficient, effective, and consistent cleaning of your entire system, not just the food contact surfaces, the system, the facility, and the grounds. Some would say if the operator and crew can't see it, they can't clean it. So think about all those hidden surfaces. The microbiologist in me loves to take things apart. The operators hate it. So when you think about the fundamentals of sanitary design for both facilities and equipment, the goal is to create that environment that's easy to maintain under the required sanitary condition. We want to start thinking about sanitation at the property line. We want to specify materials that are easy to clean, and we want to design for the expected life cycle of the facility. Right? When we think about putting in equipment, some of that equipment is around for decades, and we still need to be able to effectively clean and maintain it, and maintain that sanitary nature of when it shows up throughout every product that we make on that line. So the first set of sanitary design principles that I'll talk about today are the sanitary design principles for the food manufacturing facility itself. So when you study these design principles for facilities, you'll notice there's really 3 themes. First, the facility should be designed to eliminate cross-contamination. We talk about linear flow from raw to finished product. Facilities being designed to eliminate harborage and growth of pests and microorganisms. We don't want the rats, we don't want the lizards, we don't want the birds. As we know, we also don't want the Listeria. And we want it to be designed for effective sanitation, right? People are tasked to do this cleaning, sometimes under not the greatest of conditions. We want our people to be safe, we want the food that we make to be safe. As I try to advance the slide. All right. So the principles that I'll be talking about and referring to today are posted out in the GMA workshop, another trade association that we work with. But when you think about sanitary design principles, there are several different sources of them. I'll use these today. I encourage you to use the ones that work best for your manufacturing site. At a very high level, they get at the same important things. So again, 10 sanitary design principles for food manufacturing facilities. In the interest of time today, I'm only going to focus on the 4 that are in blue. So again, we'll use today as a starting point, and I'm going to share some pictures as well. First principle I'm going to cover today is distinct hygienic zones in the facility. So when you think about hygienic zones, you think about that movement of materials from raw to finished product. You think about maybe separation of cooked and uncooked, ready to eat, not ready to eat. You think about how you transfer a hazard along that line, movement of people, movement of materials. So the picture that you see on the left is a temporary solution to a small space zoning issue. The covered equipment is really sensitive to wet washing, so maybe there's some aluminum or some copper parts, maybe there's some electronics exposed. So it requires the operator to bag it up, cover it in plastic every sanitation cycle. Now, as we know, those of us that have worked in manufacturing facilities, stuff happens, right? You're relying on somebody to remember to do this. Oh, and by the way, they got sick and we have 3 temporary people in today. We're relying on people to remember to cover it well, and then remove it in a fashion that will not aid to contamination. Is there a better way? Well, the picture on the right is a really good example of a sliding curtain. As a well-constructed side rail, the plastic material provides protection, but it also allows operators to see what's going on both sides, right? People want to know what's going on around them, or sometimes they have a responsibility for both sides. So again, from left to right, you go to a more sanitary design. The plastic sliding curtain is a good mitigation technique, but there could be better alternatives. All right, it's about understanding what your facility needs, what processes you're trying to run. Another solution could be a permanent wall, again, depending on what the needs of the facility are. I love this slide. On the left side, or also in the circle in red, we have a dry environment. This is where dry ingredients are being mixed, dumped, and then conveyed for addition later on. On the right side, we have a wet processing area that's cleaned through wet washing. As you can see, during this sanitation shift, we were able to capture all the humidity in the air. But guess what? That dry side's not staying so dry. Those dry hydroscopic ingredients are getting sticky and nasty. Not only is it creating a microbiological risk, it is really hard to clean. The next sanitary design principle that I'll talk about today is about water accumulation controlled inside the facility. Now, when I think about our frozen food facilities, these are wet processes. Water is used for conveyance. Water is added post-freezer to help against freezer burn. And there's a lot of different steps involving water. That being said, making sure that we're designing the facility so that floors are sloping appropriately. Has anybody ever been in a facility where you have a floor drain that's high in the floor as opposed to the low point? Really not doing us any good. Water's pooling. That's what this design principle is all about, is making sure you're constructing your infrastructure to support the water movement needs and avoiding the accumulation of water. So let's look at some examples. All right, look at the one on the left where the arrow is water pipe going down, draining to the floor, traveling a few feet to a drain. I love it. It was positive. I know maybe not a surprise to you, maybe it was a surprise to me. Is there a better solution? Now the system on the right was designed so there was a CIP output going right to a drain. It has a quick disconnect. The drain was designed so that it could handle the capacity of fluid coming when the cycle was ended and we're in the big dump phase. Really nice design. I wish I could tell you that all of mine look like that, but they don't. Now what you see on the left is probably, as an auditor, one of my biggest pet peeves when I walk through one of our manufacturing sites, is the hose on the floor. The hose on the floor that will be used to spray potentially a food contact surface. The hose on the floor that I'm swabbing for pathogens. The hose on the floor where we just saw the puddle and the accumulation. On the right, a better solution, although maybe not the best solution, but the hose is up off of the ground and the nozzle is not laying on the ground. People are always surprised when I talk to them about the potential of those hose nozzles being a source of cross-contamination for Listeria, and I've sampled many of them, and I've gotten many of them back. We throw the nozzles out just as an awareness. When we do the sampling, we throw those nozzles out and we change them out. Because sometimes 3 days later, after the corporate microbiologist leaves, people forget what hose she sampled. Condensation. Every plant I go into, we look for condensation. Condensation over a product zone. It's really, really hard to manage, really hard to justify. How do you prevent it, and what are the tools and tricks in your design for heat transfer that you're building in when you work with your engineers. Freezers. We talked quite a lot about freezers in the last session. I mean, freezers have been known to be a potential source of cross-contamination for Listeria. And as we look at water control, we look at ice buildup, we look at the defrost cycle. Where is that ice all going to melt and go? How do you clean that? Where is it? And if I didn't talk enough about hoses, we managed to find some leaky hoses captured in the moment. So what you see is not only the hose providing unwanted water to the environment, you see the pooling of water on the floor. Far away is the drain. If you look closer, as you go to the drain, you might see a crack. Now, what some people will see when they see that crack in the floor in their infrastructure, they'll say, we need to fix that, but I've got 17 other things to fix today. When I go in a facility and I see a crack, I just imagine all the bacteria living in there, right? My Q-tip barely fits in there, but I know they do. So let's talk about the building itself. We talk about designing and constructing all openings in the building itself so that insects, rodents have no harborage, no birds. We want to make sure that those components are easily cleaned and inspected, free of cracks, free of welds, or voids, not welds. Welds are fine. How many people have walked on the roof of their facility? Yeah, I love going on the roof. So you go on this roof in particular, and there's bird feces. And on the right, you have cooling water. How do you clean the roof? How do you clean your shoes when you go back in the facility? What if you just tracked back in? So roof design, appropriate sloping, and appropriate drain, incredibly important. Also, obstructions to flow. So we see on the left the picture, there's a great drain, works really well. The flow can't get there because they put other things there that are blocking it. On the right, we got the HVAC system condensate going, pooling, not really making it to the drain. I know of a great story, talk about what is really the likelihood of this. So I'll share with you a story that happened at a facility that I work with where we had a finished product salmonella positive. And we were really pondering, where would this happen? Where is this? We're investigating, how could this happen? We've never, ever had it happen before. So after much investigation, I'll give you the short version of the story. We had the bird on the roof, the pigeon problem, the poop, not in the same picture, but you can imagine. We had a rainstorm. We had a crack in the roof and a roof leak. The roof leak was in the maintenance area where the food contact parts were. And wouldn't you know, it was dripping on the food contact parts and the rakes that were used. Genetic match from the roof and the final product. It was a sad day. It was a happy day as a microbiologist because we actually found root cause. Really, we're focused on the importance of maintaining the building itself. Yeah, I saw as I walked in, somebody was producing or advertising a solution for bird control, so I need to stop and visit them on the way out. We want to make sure that the building itself doesn't provide nesting areas and roosting areas. And after the experience I've had, I'm especially sensitive to this. The other thing that I ran into at one of my facilities is some birds are protected. Once they take up roost, you're really not allowed to get rid of them. And I don't want to endanger the species. I don't want to endanger my food. It's a precarious balance. All right, I'll try not to dwell on birds anymore. Interior spatial design facilitates sanitation. So what does that mean? Well, some principles covered in this one are aisles wide enough for maintenance, sanitation, and materials. Sufficient access to clean the building. Can you actually get to stuff? I mean, with production space is at a premium. We want to get as much into our buildings as possible. We also need to be able to navigate around and effectively clean them. We also want to look at those floor, wall, and ceiling interfaces. Are there areas that can produce or wind up having harbor spots for pests. You know, we focus so much on product zones that sometimes we forget to look up and say, wow, there's some opportunity. And sometimes we underestimate just how far those high pressure hoses can spray. And they make it to the ceiling, and what they bring down is sometimes really not what you wanted. So remember to look up as you're walking around the facility and look for those areas that are harborage points for pests, product, dust. In this picture we have a series of some nice examples of those interfaces. You see the I-beam cemented into the ceiling, the wall sealed to the ceiling. Better design. Initial cost is probably going to be a little bit more, and your project engineer might not like it. So you have discussions around what does it take to clean. Long-term maintenance costs are probably going to offset that cost of what it's going to take to bring in a contractor and clean it under the other conditions. Floor wall interfaces, one of my favorites to go looking for Listeria. This is a great picture. It's a cove-type junction. It's continuously sealed. It's covered. I love the little plastic flaps that you caulk on there, because caulk protects everything, right? It's the first place I swab. Find stuff there all the time. So many of our incidences where we've really struggled to find the root cause, we've peeled back some flaps and found that harborage in there was getting wet during sanitation and then all winding up in the drain. Caulk, caulk, caulk. Utility systems designed to prevent contamination, right? So our surface is cleanable to a microbiological level. Are they using appropriate materials? Is there access for cleaning? Is the water going to the right place? Back to that water theme again. How about the lighting? Can you actually see? Is it bright enough? Anybody ever been in a production facility where it was a little bit like a cave and you wanted a splunking light? Or how about the facility that then did a great job of adding additional lighting, but it was glass, and that didn't have the appropriate sealant to do, so to make it shatterproof. So good reminder around our glass and hard boiled plastics as well. I love this picture. What do you see in this picture? Look at that, the wall over the drain. Isn't that awesome? That is great. Right, and done with the best of intents, right? They needed to build a wall because they wanted a physical separation between two lines. It was a great idea. They were moving away from that temporary plastic sheeting, right? Nobody actually walked out there to see where the drain was. Wall eventually started to erode, and needless to say, there was another harborage point. It was because, the first reaction was, well, it's a wall, it's really hard to move. And once you have Listeria in there, it's another conversation. All right, so that's our very rapid tour of facility, making sure our facilities are designed to eliminate the potential for cross-contamination, to eliminate those harborage points for growth of pests or microorganisms, and designing them so that our teams can clean them. So let's move to equipment, and we are in an equipment playground. Again, sanitary design for food processing equipment is an easy concept, right? We should be able to clean it. As we all in this room know, it's really challenging to implement. The design principles focus on really two key parameters. We want to make sure we're constructed to ensure effective, efficient cleaning of the equipment over its entire lifespan, and designed to prevent microbial pest survival or growth or reproduction on both the product and the non-product streams. Simple enough, right? So again, 10 sanitary design principles. I'm going to focus on 3 of them today. Each of these principles have multiple components, so you might want to get your checklist out. I'm not going to cover them, but again, there's lots of great reference material out there. Is it cleanable? The very first question that we ask. Equipment should be constructed so it's cleanable to a GMP level. And when I say GMP level, I talk about biological, chemical, and physical. We want to make sure that when we bring this equipment in, that we can effectively get our material off of it. Valves. I love valves. As a microbiologist, there is nothing better than taking these apart and swabbing them. because we like to find stuff, right? It's really important you have the right valve for the right application, and that if you have a valve that cannot be cleaned in place, that you're doing adequate tear down to ensure that it's actually getting clean where you think it is. As you can see the picture on the right, this one did not get clean. This is after a sanitation cycle. Butterfly valves, they are so fun, right? They are great, they serve a great purpose, but again, you need to tear them down in order to get to the components that are going to cause you problems later. And it's not easy. My team's always lost a part. And my maintenance man was mad because we kept using the same part over and over again. So that's when I said, well, maybe we could put an inline pump in that's cleanable. How many years would that payback take? Right, there are sanitary valves that can, if you have a cleaning place system that you can use, and they work really well. Another one of my favorite pictures. Here's inside of one of our tanks. Beautiful job. Look at that stainless steel shine. This picture where you're looking at is the very bottom of a very deep tank, taller than me, although many things are taller than me. Oh, let me go back. However, when we asked maintenance to take this apart, we found a lot of debris post-sanitation in an area that we didn't expect. And in this particular case, it actually was an allergen issue. So we had to do quite a bit of work to remediate and redesign this tank and put interim procedures in place. The really hard thing around this particular site, the tank size was so large, it was confined space. So we really had to think through not only the food safety, but the human safety as we were addressing this issue. Moral of the story is, every once in a while, take things apart. You know, in this example for Principle 1 in Cleanable is about the scraper bar. On this particular scraper bar that you see up top, bolted in place, you need tools to take it off. Not a great design. When you take it apart, where those mated surfaces were, all kinds of food in there. And let me tell you, it smelled. So, not a great design. In this picture, we have the alternative solution that we went with. It's a snap in, snap out of place scraper blade, no tools required, so people can get in there, get it out, get it clean, and get it back in place fairly easily. Still a little bit of debris that we found in there, but not nearly at the level of the other design. With the ease of it being able to be taken apart, it was a really good solution for our teams. All right. Let's move on to the next principle, accessible for inspection, maintenance, and cleaning and sanitation. All right, pretty obvious, right? We got to be able to inspect, we got to be able to get to it. So great solution, right? It's clear, I can see it. I can see the debris that's there. Maybe some mold growths, we got some pretty colors of the rainbow going on there. Yeah, it's a great example of, we see this a lot in our facilities. Two different surfaces mated together, joined together, create a harborage point. Not easy to take off. You need to carry that tool around with you. Not an easy, effective way. In this picture, you see equipment not readily accessible. Valve up in the air, about 35 pounds it weighs and about 18 feet in the air. You need a special team to get there. If the team needs to do that important routine maintenance of removing the O-rings and replacing gaskets, there's some significant safety risks associated with that. You need to bring the team in, have the lift, they need to be strapped down and have certain training in order to do it. So again, was that the best place to put that particular unit up? They maybe could have put it somewhere else. Hollow areas eliminated or sealed. This one is so easy, right? It's a great one when you're walking through a facility to really look at what are some things that I can get at right away. Those hollow areas of equipment should be eliminated wherever possible or permanently sealed. So you think about bolts and studs. You think about nameplates being continuously welded. So picture on the left, we have a penetration into the frame. On the right, we have hardware being improperly mounted into the frame by bolting and tubing. So what's going to happen when someone comes with a hose the next night to clean? It's all going to get wet on the inside and it has no way to get out. They're probably going to drive some food material in there. It's probably going to stink. Yeah, another great and easy example, right? These are the kind of things that it's so easy to become facility blind to as you walk through your facility every day. A great hollow spot right there in the framework. You can see the pieces of vegetable material in there floating. There's absolutely no way to clean that. And the particular tubing goes on and on and on. You know you're getting splashback. So when you think about equipment, you think about cleanable, you think about being constructed to ensure effective and efficient sanitation, preventing recontamination. You want to prevent the harborage area of these pests, these microbes. Again, it's a really easy concept, but it's really difficult to implement. So, as we think about these principles, I encourage you to find the checklist, to read them, study them. I would do it as you're walking through the show over the next couple days, as you're talking to equipment manufacturers. Ask them what they're doing with sanitary design for their equipment. How are they implementing it? Look in the equipment that's here today. Look for those hollow areas. Look for those pieces that need to be disassembled using tools. Ask them how they clean it. Ask them if they've ever tried to clean it. I am on a personal mission at my company that every project manager, I want them to clean their own equipment. I am on a mission. I'll take one, but as a start. Because as they put it in, they need to understand the ramifications for the next time they design. All right. So talked a lot. My throat's getting a little sore, so I'm going to turn this over to you guys now, and I'm going to share some pictures, and I want you to think about design or execution. We talked about sanitary design principles for equipment. We talk about execution of the sanitation. So let's see what we see in the pictures. I'm being told I'm not loud enough. Oh, we have a microphone. Excellent. All right. First picture, what do you see? I'm sharing them. Come on. What do you see in this picture? Donna will call on you.
There's no wrong answers.
No wrong answers. So you see the raincoats and what else? You use the microphone.
Water might drip and collect on the floor.
Mm-hmm. They're very nicely organized, aren't they? Right, they did a nice job. They have some personal belongings. Oh, somebody in the back.
They're touching the ground.
They're touching the ground, yes. Design or execution. What do you see in the background there? Anybody see the floor drain? They're hanging over the floor drain. How awesome is that? So this is the uniform that our teams are wearing to clean the equipment. They're now very nicely hanging, some touching the floor, some touching what appears to be personal materials, and who knows what's going through that drain. Great, good. All right, let's try another one. What do you see? Design or execution? Oh.
Any guesses? It's a shadow board missing some tools.
Yep, a shadow box missing some tools, so hopefully somebody's out using them right now. Right, it's very clear, pokey oak, I know where to put it.
You've got pockets for harborage where the tools are stored.
Yeah, how do you clean that little square out? That wrench looks a little dirty, doesn't it? Maybe my tool didn't get cleaned before I went back. Good. All right. What do you see?
Those little blue feet that can't be taken off because they're screws above ready-to-eat product. And I see the little red circle, which means one of the little feet got broken off, so it's in product. You probably ate it when you ate those chips. And then you've kind of got the area that the ledge that you've got old chips that can sit up there, and drop into good products. So you have lots of contamination points.
Yes,
Awesome, guys.
great. Our sanitation teams, they work really hard. We were talking about this with Marty during the break. Right, if you've done sanitation, you know it's a hard job. It's a hot, sweaty, dirty job. And it's a job that it's sometimes more of an art than a science. These are some examples of some of the most creative tools that I've found. And while I applaud the design creativity of our people to get the job done that they need to do in the time they need to do it, I'm not sure how they clean any of that. I'm not sure how effective any of those tools are. Surely we can help them out and do better. And what I find fascinating about these tools is these are closely guarded tools. They have worked hard to design them and they don't want you taking them away. All right, what do you see in these pictures?
Got lots of harborage around all those cables.
Lots of harborage around the cables, right? We talked about processing space is at a premium. You might need that extra 300 yards of cable at some point. I don't know how you're going to clean it in the meantime, but you never know when that might come in handy, right? And all the cableways overhead or underneath, depending on where they put them on that particular project, right? Are there better ways? What do you see in this picture? Yeah, access is important, right? We want to make sure operators have the proper reach of their equipment. But I love that not only is the deck over top of the drain, but so is the equipment. Yes. All right, if somebody can help me understand this picture, that'd be great.
So I see condensate blow through, so there's a problem in a steam trap upstream, so shitty maintenance to start with.
Yep.
Followed by more following that theme with the plunger. That might be tied to the same theme. And let's see, I can't even tell what everything, it looks like a contractor's been in there and they haven't picked up any of their product after a project. And whatever that rusted thing is over to the left, could have been the inside of a fan or something else. Maybe it's rusted because the condensate's blowing through, I'm not sure.
It could be, right? One problem's created another, so definitely one in the
I
execution.
see you've really just kind of circled the plunger and the electrical conduit, but I'm kind of more worried about the condensate blow through myself.
I was trying to distract you. All right, frozen pancakes. I have 2 kids in college, and this is really a life-saving product for them. I think they go through a box a day. And if anybody thinks that they are ready to cook, let me assure you, in my household, these are ready to eat. Cooking is not in their vocabulary as they're going to class during the day. So we talked about control of water earlier. So it may be a little hard to see, the monitors are a little small. There's actually water being sprayed onto the surface of the pancakes in a not so uniform fashion. And then all of it, what you can't see underneath, is actually just spewing out everywhere. So stagnant pooling water as a result of the process itself. One last picture, everyone, then I'll let you off the hook. There are 2 people in the picture, by the way. So they're sanitation crew trying to do their job, and that's how it was designed for them to do. All right, so as we wrap up for the day, I think it's really important to recognize the importance and the impact and the interaction between sanitary design principles and sanitation. And I put on here supporting food safety, but I would also add the importance of human safety for the people that we have working in these systems. You need to really work early and often on this topic Although I would say you can also go and look at your existing assets through these lenses to say, where can I improve? It's also a really good opportunity to really familiarize yourself with the tools, with existing assets, so that you know how you want to do it in the future. Use all of your resources, and at the end of the day, I think there really is a lot of value that comes from this conversation. The better we get at sanitation and sanitary design, the better we are prepping our plants to make safe product every day. Lots of reference materials out there. I encourage you to use them. Again, combination of sanitary design, sanitation execution, effective, efficient, and sustainable. And that's all I have for you today.
All right, do we have any questions for Kelly?
So Kelly, your examples were wonderful. You could probably find them in any manufacturer's plants. So the question I have back to you, I realize you're on the quality side, but how do you take these observations from factories and integrate them into both the packaging equipment designers' standards as well as General Mills standards? I mean, there has to be a way that you see this one-off. You talked about in your previous presentation about creating a sustainable process to eliminate that, but part of that is to make sure it's a part of your design and engineering standards. So talk about that a little bit.
Yeah, it's a really great question, right? And, as you look at these standards and you look at the understanding and the implementation of them throughout, it really starts with the people who are designing equipment and the expectations that I have as a customer for that equipment to ensure that we're talking the same conversation. So in my role, it's really important that my best friends are engineers. And I have to learn to talk a different language with my engineering team. If I go in and go, hey, check out how much Listeria I have, they're going, what are you talking about? Well, let me help you understand the risks and the implications of not being able to clean effectively. It not only has a regulatory risk, it has a food safety risk, and here's my labor implications. And by having those conversations and those partnerships then helps us to design what our criteria are inside, what our needs are for a wet system and a dry system, and really start putting it into our purchasing contracts. And design reviews. We are doing that, yes.
Great. Next question.
I was wondering, we've been seeing a lot of antimicrobial treatments to floors, walls, things like that. Do you have an opinion on that? I mean, is it working? Is it just kind of hype? What do you think as a microbiologist?
One of the things that we talk about is what's the longevity of that treatment, right? Totally understand and get the science behind the materials that they're using, absolutely have antimicrobial nature. How does that stand up to repeated washings every day for the life cycle of the facility and the equipment? And we also have to, when you talk about floors, we have to layer in the human safety risk of what does that do to the slip properties and how people are moving through facilities. So that is the data that I haven't seen yet, and until we see that, we haven't done a lot of traction in that area.
Other questions?
How do you decide whether a plant is just not recoverable and you have to start new?
Oh, that is a great question. I don't know because I haven't come across that yet. And we've had some big challenges. Starting at the very fundamental of working with a facility that still had holes in the infrastructure, so the bird was coming in and saying hello, and some very fundamental things. I don't know, does anybody know? When do you say no? Maybe when the only negative you can find is outside the building? That might be a good start. When you cannot produce food through your testing program that is tested to be safe and you're consistently making product with pathogen or doesn't meet your quality indicator, maybe that data would lead you to that.
Or if FDA or USDA shuts you down.
Yeah, if our regulatory bodies share with us that they feel that we don't need to be producing anymore, That would be another great hint.
See, as you can see, it hasn't happened at General Mills yet, but there have been cases where that has happened for some companies.
Like an ice cream company.
Other questions for Kelly? Well, we will stick around for a little bit of time, so if you want to ask your questions in private, you can do so. But I want to take this opportunity to thank Kelly again.
Thank you, Donna.
And thank you for attending these workshops today, and thanks to PROCESS EXPO for allowing the frozen food sector to have sessions related to Listeria monocytogenes. Enjoy the rest of your show. Thank you so much.
Remember, it's a learning lab.